Okay, so let's just think about these. If you were doing the millionth term, that would be 3 times 0.97 to the millionth. But when you take 0.97, if you even tried to type that in your calculator, I'm going to try right now. You try 2 with me. It's going to tell you it's 0. Now, you know it's not really 0. It's some number that's super close to 0. So we know because you only get 0 if you times something by 0. But because this number is less than 1 and bigger than 0, you know it's going to get smaller and smaller and smaller. So you know this is about 0. Now, when you look at this one, let's to the millionth. What happens when you take a number like 1.03 to the millionth? Well, that's going to get huge. Why is it going to get huge? Because when you multiply a number that's bigger than 1 by itself again and again, it grows. And in fact, I even tried to type that in my calculator. It would tell me overflow. It's just too much. So you know this is some kind of huge number. I wonder if anybody wrote down this symbol for plus infinity. Okay, let's look at the next one. Okay, if you do 0.97 to a million, that is almost 0 again. So this is about the cosine of 0. But back to where we started together, the cosine of 0 is 1. What about this one? If you do 1 divided by, this is like still a pretty big number. The square root of a million is still pretty big. Okay, so this is about some real number that is super close to 0. I could actually get it on my calculator. It's 0.001. It's pretty close to 0. Okay, so this idea is like thinking about sequences and what happens as you make their input terms bigger and bigger and bigger. That's really the big idea. It's our bridge to our next thing we're going to start thinking about as we head towards calculus.